Ba 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 bra ba 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 bra ba 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 bra 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 ba 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 bra bra ba da ba 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 ba. Here we go. Get that nice in the background. Boo 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 do 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 boo do 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 boo do 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 boo do 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 do. Whoops. Okay, here we go. Having a code. Ah. Oh no. Its civilization on Pluto was known for its ability to manipulate space-time, while the historians explored their infinite corridors. They've remained normal stones, perfectly shown. Each stone has a number engraved on it. 902. Okay. I'm. Every time you blink, the stones each simultaneously change according to the first applicable rule in this list. When it goes to the number 0, is replaced by a stone engraved with the number 1. The stone is engraved with a number that has an even number of digits. Is replaced by 2 stones. The left half of the digits are engraved on the new left stone. The right half of the digits are engraved on the new right stone. The new numbers don't keep escalating zeros. Okay. If none of the other rules apply, that stone is replaced by a new stone. The old stone's number multiplied by 2024 is together with the new stone. No matter how the stones change, their order is preserved and they stay on their perfectly straight line. How the stones evolve, if you keep blinking at them, you take a note of the number engraved on each stone in the line, puzzle input. You have a range of sizes like this. Okay. So, how many steps? For I in range 25, for item in, so we're going to call temp equals split data right here. For item in temp Yeah, we're gonna be repopulating a new temp. Equals temp. Temp equals temp 2. We're gonna do this every single time. For item and temp, if item equals 0, then temp plus append temp2 dot append 1. If len item mod 2 equals 0, then temp2 dot append string item okay, colon that should be correct. Okay. Boop, boop, boop. Boop, 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 boop. $9.19 double equals. Okay, num equals len item divided by 2. Um, yep, we split by space. Oh, and temp 2 equals empty. I was gonna say equals temp. I mean, I shouldn't be dot copy because it could be something weird with. Ah! I gotta do this after. Like this. 152722? That's the right answer. Okay. So here I'm gonna do print temp 2. I have to floor it like this. One five six seven one three 9 8 7 6 5 4. Not the right answer. What? Okay. Oh, wait a second. Yeah, so after one blank, this is what it'll end up being. So 9 and 2. 1. 28641. 8034. 3. Oh yeah, so it's that number times 2024. What the hell? 4152213 736. 2024. Oh, I did say, okay, yes, that's correct. It should be temp 2 at the very end because we haven't set temp 1 to be a temp 2 copy. That's the correct number. There we go. Looks way more correct. That's the right answer. Cool. Part 2. Be fair. There's 75. Well, let's see if it breaks. Oh, I should probably... There we go. Hopefully it shouldn't take very long. Ba 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 da da ba ba da ba da ba 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 da ba ba da 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 ba ba da da ba ba da ba da ba ba da ba 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 da ba da da ba ba da ba 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 bum ba 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 bra da da ba 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 da ba da ba 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 da da ba ba da ba da ba ba dum bum ba da 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 dum ba ba dum bum ba da da. Okay. I think the correct path here would be, the correct way to do this would be to figure out how 2024 grows. Because I think 2024, if you just look at those numbers, 2024, becomes in one split 20 and 24, then it becomes 2024, and then it becomes 4048 1 4048 8096, and then it splits even further. Tuple index out of range. What? Okay. Let's just do this. If I just run 0. Well, actually, let's not even run it for 75. Let's do it for 25, because I know that my program can do that. Right? So if I can just test zeros, then whenever I get a 0, or actually I can do all the single digits. Whenever I get any single digit, I will just output a number into the thing and then pop it out from my group entirely, right? Okay, so let's just print temp2. Wow, just with 0? That's what 0 turns into after fucking... Okay. So... That's... annoying. 75 is going to be too much, actually, because, like... In a worst-case scenario, we're looking at doubling these every time. Ba, 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 ba. If item equals 0 and I equals 0, there, that. L if item equals 0, zero index equals append I. This is when every single 0 that comes through, and it'll ignore all of them except for the very, very first one. Okay. So all the 0s, except for the ones that were generated on the last step, are gone. Wow. Okay. So that's how many 0s are just generated normally. But now if I can do the exact same thing with 2s, with 1s, 2s, 3s, 4s, 5s, 6s, 7s, 8s, 9s, then I don't need to worry about those specific numbers ever again. And when they come in, I can just give them a number, right? Thing is, oh my god. This is still too many. How many is it? It's just the number 0? 8,000 is not that bad, actually. Ba 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 ba. Okay. So there's got to be a way that lets me do this in a cheaper way, right? Oh, actually, what if I do... That's not correct. Yeah, no, okay. Oh, that's alphabetical. Okay. So I'll attempt 3. This should be correct. Okay. Could I do... I mean... Only 8 digits. That's really not that bad. I was expecting it to be way worse. So I could create a list that looks through all the numbers and then tries to evaluate if they have recursion in them. And then if for all the low numbers, you just put them into a thing. Bum, ba-dum, bum, ba-dum, 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 bum, bum, ba-dum, 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 bum, bum, ba-dum, ba-dum, bum, 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 bum. So 8-digit numbers aren't a problem because they become 4 digits, which become 2 digits, become 1-digit numbers. And then we can just do the 1 digits. The problem is when we have a 7-digit number. We'll call that an N index. So a 92... index is empty. Oh. Okay. So we have a 9 and a 2 in the initial stage. So if I do 2, 8, 6, 0, 4, 1, then that's what you can break it down into. Okay. That's tolerable. If we can take the initial numbers and put them into single digits, then we can iterate on the single digits, say what happens after one blink, and then repeat that forever, right? So if now we just do equals temp.copy, okay. Will it let me do 50? It will. It's a lot, but that's a tolerable amount. Will it let me do 75? It's actually not that many. It does let me do 75. Okay. So now we need to create a table that's... Wait, yeah, this totally fucking works. That's so cool. Okay, cool. So we are going to have test case. Yeah, because we can just loop all of these into it, right? We don't care how big these are. We just count however many there are in the end there. So test case equals 0. Don't even do that. For I in range 10. What fucking song is this? This is a good song. Let's see, Freda? Yeah. This sounds like something you'd hear in, like, Monogatari. This is a fucking banger-ass song. So... Well, no, we could just do... case data. Well, no, we probably want to take all of this specifically. Yeah. We have Temp 3, which holds the final details here. Oh. Because what we want to do now is if we could take each of the individual numbers and say what happens to them after one step, then we could create an entire table that says you go from this number to this many on that step. And then we just go through the entire final Temp 3 list. Yes, let's just kill this. Because zeros becomes 1. 1 becomes 2024. Do any of the numbers not eventually resolve to... That's so fucky. So I could do it all by hand, but I don't want to. I'm just trying to wrap my mind around how I would conceptualize this issue. I wanted to write to my brother that this problem is often. Sorry, I realize you can't actually see my keyboard. It's not online, but that's fine. Sorry about that. Okay, so what I'm going to do is I'm going to make output check. So output check j dot append, or it doesn't even need to be dot append. It's just yeah, dot append. It just needs to be dot append. Ba, 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 ba. Oh, this is tough to build and conceptualize. I understand what I need to do. So ah, list indices must be integers or slices, not string. Wait, I can just run this all and it doesn't take that much time at all. That's what I meant to do. Ba, 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 da, ba, 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 ba. Okay, so Actually, I didn't even do that because it just. Okay. So, 0 becomes 1 and stops. That's reasonable. Okay. Okay, I see what the problem is. And I equals 0. That's right, and does not equal 0. So, um, yeah, 2024, 4048, 6072, 8096. Yeah. So then it becomes, a couple steps later, 20482880. Does it all impact on the same turn every single time? No. This one doesn't. 8 doesn't. Ba-da, ba-da-dum, ba-da-da-dum, bum, ba-da-da-da, ba-da-ba. This is the N index that we have at the very end. What if I do instead print output check? So this is very good information, if what we want anyways. Because now we can create a list from there. But I want to check what output check is, because this is going to be a disaster. Okay. So the very first thing I see here. You need to put that into a... Let's remove one of the extra brackets here. That'll be a little bit goofy. So, okay. Ba-da-dum, ba-da-da-dum. It takes, so it'll show us every step of the way, temp 2. So, at the very beginning, for our case of 0, let's actually do this just for... That should work then. But now, if len temp equals 0, then break. That should reduce this gobbledygook significantly. So we won't be seeing the exact same thing and repeat over and over and over again. So yeah, here we go. So in the first step, one, and it holds 1, 1. Then it's an empty frame, and this is what 1, 1 holds. So this is the end of case 1. That's all we actually need. So if I do len of temp 2, then this should just print out how many things, how many digits there are in every state. So I don't know why there's a 0, 1 in all of these. So They all have. There's one, two, four, three. Oh, I don't need to put this at the end of here. I put this at the end here. And this gives us the useful output. This is how many digits there are in at every single step. So we take the list of all the things, and we continue to reduce and count all of them up until we have a list of things and a list of steps. How many steps away do we have to consider? Okay. So what I should be able to do is to whatever the final output is in all of the non-zero values and just, cool, they're all counted. Cool. But all the other ones we've intervened on, we have a large array of digits and when they were acquired. So in step 0, we catch an 8. Then in step 1, we catch all of these. So for pair in n index, because this number is just going to be the flat amount we're going to care of the non-individual digits shit. That's fine. Actually, you know what we could do? Nah, let's not bother. Okay. Ba-ba-da. Ba-da. Endgame check. We're going to do the exact same thing, but So for parent and index, if pair 0 while pair 0 is less than 70, well, we actually probably just should count. Okay, so let's make a table. This shouldn't have any 75s at the end, right? Just go 74. So it should be 76. So 75 is fine. Okay. Blink count equals oh, okay. Now maybe instead of doing it this way, we take the list we currently have. God, this is so complex. Fuck. I know I can do it. This is one that I know that I can do, but oh, it should be actually len and index. But it should be. There we go. Okay, that's correct. So we want to create a table. Yeah. Cool. So So I want to create a 75 by 10 table that recorded every single step, how many of each there are. Yeah, that works. Okay. I can do that. Well, somebody. Okay, it should be like this. So at the end of this, I'm going to append whatever I get to num table. So it'll be whatever digit it is. Actually, yeah, it'll be even easier at the end. But yeah, it'll be digit. It'll be a big list. Whichever index is the one we're going to care about. And then every index after that is going to be how do we convert those numbers into something else, depending on when it was received. Okay. So output. So we want to have this the len end index here. If I do end game check, actually, if we should just put in length of end index. That's all that matters, right? Because this will be accounted for eventually, right? Um, or for q in len or in range of len of temp num table. So temp num For the end index, just so I can remember. I'm also going to copy this just so I don't forget. Oh, it's the Spectral Casino. Song's a baller. Absolute banger of a song. That's what I want to have. There you go. Let's actually change it up a little bit and do this instead. That might... Whoops. There you go. Um... But nothing is appending it, because this is an elif. Oh, I don't need to string it. The string of an item will put in bullshit, because it thinks the quotes are part of the string that you want to add in. Why is that 3? And then why is that... Why is it duplicated? Because 1 becomes 2024. Ah. Yeah. I want something after every fucking step. This doesn't work. Oh. That's what I need to do. I'm double growing it, because I have one that's growing every single time, and I'm appending every single time I add it. That's why it's getting so fucking weird and large. Cool, there we go. Okay, so that's 1. So this, we will append x count. Oh god, this is so many variables to keep track of. It is genuinely getting overwhelming. Because I know conceptually what I need to do, but it's just so hard to apply it in practice. This might be an example of a day that I won't be able to finish again today. You think part 2 was easier than part 1? I know what I need to do conceptually, but also, fuck off, it's easier than it is objectively harder than part 1. Because what I need to do is, because that Python can't take variables of this size. So what I need to do is to figure out, I'm looking at all the single digit numbers, 0 through 9, and saying, when I have a 0, how many will that eventually create n steps in the future? The problem is that this question is iterative. So I start by saying, how many steps does 0 take if you do 1 step? 2 steps, 3 steps, 4 steps, and 5 steps. Well, actually, you just do 1 step for all of them. And then you do 2 steps for all of them, 3 steps, 4 steps, 5 steps for all of them. And then you have to recursively go back through, because it is a recursive function. But I don't know how to apply that recursive function, and I am getting a headache, and I'm thinking about it too deeply. I need a reset. I am too in the weeds right now. I can't finish this problem right now. I would go to other problems and revisit it if I could. I'm going to sign off for tonight, because I think I could do it before 2 o'clock. But I would need to wipe everything and just start fresh. And I'd rather do that with a fresh mind. Because I know what the fuck to do. I know what I need to do. I just can't figure out the friggin' application. Because it's so difficult to mentally map this structure. Because, okay, so I have 0... because it just looks at, it says it's 1, but 1 step later. So it basically says 0.75. By taking a function 0.75, it will output 174. Because that's all it is now. It is just 174. But 174 outputs 2 and 72, 0 and 72, 2 and 72, and 4 and 72. That's the problem. I need to take an array of all these, and I also need to have a thing at the end that's going to count how many extraneous bullshit comes out of it. Actually, I don't even need to do that, because it's not going to apply, because we just know how many there are, how much extraneous bullshit there is in the end. But, I need a way so that I can easily say one of these becomes something else how far along the way. And I'm having a lot of genuine difficulty assessing that right now, because I need to have an individual separate fucking 2-dimensional array for every single digit, which creates a 3-dimensional array. Because I need to have... Yeah. Oh my god, dude, this is... I don't want to do it manually, right? I don't want to do it manually. That's the problem here, is that I want to not do it manually, but everything in my fucking body is screaming, just hard code the fucking numbers. And it's driving me insane, because I can't think of any other way of doing it. I actually just cannot think of a way to do this in a way that's like kind of clean and easy to fucking do. Everything is like telling me to just like, oh, just use fucking 4-dimensional arrays, it'll be fine. But it's all like, look at how unreadable this is. Python output for these kinds of arrays fucking sucks. But like, that's what it is, right? I'm looking at the fucking answer right here, right? After 1 step, 0 just becomes 1. After 3 steps, 1 becomes 2024. After 3 steps, 2 becomes 4048. I'm hard coding it. Fuck it. The fuck is this? Windfall Island? Oh, this is one of the extra islands I haven't seen yet. Eight oh nine six. Eight eight oh. Two four five seven. Nine four five six. Wait, I think I just thought of a different way. Um, uh, because what I can do is I can have a string, because these are just digits, right? These are just digits. That's all we give a shit about. They're just digits. I can replace digits with other digits with a delay. Okay. So, what the fuck we have here? How do I create, like if we start with 8, then okay, so oh my god. Okay. So I can replace this, and instead of adding to an n index, I can just do n index I plus equals item. Um, per num is equal to um, n index I. So split string by characters Python. Just list. Okay. For are in list and per num if car equals 1 equals 0, then n index I plus 1 plus equals 1. Because it doesn't matter, right? We could just iterate and just add on to the end of all of them. Make a really, really long string of all of them. That should just work, right? Is there a maximum string length? Or is it going to start breaking at some point? It's got to start breaking at some point, right? Oh, that would work, wouldn't it? Num count. Okay, yeah, let's do that. Num count. Four are in n. What's it called? N index I. Okay. Or q in num count I. Okay, so num count I plus 1 Okay, so I do it like that. That'll actually work. 1, 2. Okay. I'm putting this into a different metric here because this is beginning to fucking stress me out. This is the only split one. Okay, so that's now handled. Now I need to handle all of the plus 3s. Maybe a bunch of them. And 3, 4, 5. But not 6. But yes, 7. And that is all the zeros done. So, stage 2. Wait, nope. 1, 2, 3, 4, 2 on 5. Ah, these actually go plus 5 at the end, not plus 3. So that's all the ones we have there. So now we have 2s. Okay, we have no 1s. We do have a 2, though. Um, 2 times case 1, 3, and a case 3. There are no 3s that get brought over, but there is one for the first case here, plus 2 times the second case, and that's it. No 5s, but there is 6s. One on a 3 and one on a 4. Eight, we have 2 and 4. And 9. Oh, there's actually a 7. There's a 7. A 9 is just a 4. These are all plus 3s. Interesting that 8 turns into an 8 later. That's the only case where there's a 4. Okay. We have 2 from 5. None. 1 from 7. None elsewhere. Ones. 1 from 9, and that's it. Dude, this is stressing me out right now. Two from 5. One from 6. 2 from 7. Two from 8. None from 9. Threes. 1 from 7. One from 8 and 1 from 9. One from 5. 2 from 6. One from 9. Two from 6. And that's it seems. We'll revisit just in case. We have 3 here. 5, so let me just get rid of that. Now we have 1 from 7, 2 from 9. One, 2, 1, 2. One, 1, 2. Six and 9. Okay. That's just done now. So now this should populate the num count range with how many of each we need. So let's do print num count. And this is just going to give us well, actually, let's just do num count. No. Yeah. Fuck it, let's do num count. Let's see what happens if you just print out num count. Oh, it's almost at 2. Are you still watching? I have no idea if you're actually still there, or if I'm just... Or I'm just doing this on... What? Oh. I'm... Yeah. It says there's still 2 people watching, but I'm honestly getting very antsy and tired. You fail again? Setting 8 out of range? Why? Oh, shit. Numcut I dot append. That's what I needed to do. That's what I'm doing wrong. $78. Int object is not iterable. What? None of this matters anymore. Okay, let's just see what it says. Everything wrong? Oh yeah, because append. Yeah. Okay, I see what the issue is. We're going to be on 2. Okay. Turned error. Oh, right. Duh. Oh, wait, did I print out something else? Whoopsies. Four, 5, 6, 7, 8, 10. Okay, so we print the length of temp 3. So print the length of temp 3 plus this is my last guess. If this is correct, I'm happy and I'm going to bed. Sorry, this should be 74 0 because it's the last count. Final answer. It's too low. Okay. Oh, but it does it do anything else, or no? That's all that it does, right? Because all single-digit numbers will always default back to single-digit numbers eventually. In 5 steps or less. Yeah, this should be correct. I don't know what's wrong right now, and I'm just... Question is the number of stones at the end, right? Okay. Step total equals 75. Ah, no, okay. Because I do actually have a couple more that I have to count. Because, yep, because that there's in-between steps that I haven't considered. So, per step equals this. That's the current step. And then previous step equals that's this now, right? It starts with 1 becomes 0. This one goes to gets 1 item, then 2, then 4, then 0. So, minus 1. So it starts with a number and then becomes 2048. It becomes 2048 and then becomes that in 3 steps. And 4. Well, this one doesn't count. So, yeah, the last one doesn't count in all of these. So, first of all, get rid of the zeros. Okay. So, instead of counting the number of digits we have now, we say, well, if on the previous step we had this digit, then it will give us still 1. But then it gives us 2. But then it gave us 4. But then that's this current step. So yeah, we want to count the previous step. Yeah, because we're counting -1 right now. So yeah, we don't count this. Okay, cool. Previous step 1. I'm gonna do 2, 3, 4, 5, 6, 7, 8, 9. I don't care. This is jank. Okay, so that's the same. But then instead of going 1, 2, and we actually remove the last one on each of these two. So remove the 1 off of all of them because we're counting that. Whoops. And now we remove the biggest number from each. Oh no, we don't remove the 1 off of these. Because they all turn to 1s. Is we remove the last number off of all of them. Okay. So we have 1, then 2, 1, then 2, 1, then 2, 1, then 2. And now we have 4 step. For step 5, we have 1, 1, 2, 4. Whoa. One, 1, 2, 4. And the rest of them are 1, 1, 2, 4s. Yeah. This is my last shot, and if I don't get this, I'm going to bed. Good night. Still too low. I'm missing something else here, and I'm don't have the energy to do it anymore. Thank you for watching. Hope you guys enjoyed, and I will see you all next time. I will figure this out later. This is giving me a headache, and I've already pushed past the 2 o'clock time, so I'm going to bed.